Okay, this next video is about the Tiger handout. So let's go over how to do these problems. Again, this Tiger handout is about scientific notation. This time, however, we're looking at very small numbers. So let's review what that means for scientific notation. All right, on your math notes, math toolkit, these are examples of very small numbers in scientific notation. And let's take a look at these in a little more detail. Scientific notation for very small numbers has two things that are exactly the same as it is for large numbers, and one big difference. The two things that are the same are that the first factor here still needs to be less than 10 and larger than or equal to 1. The second factor, another thing that's the same, is the second factor needs to be a power of 10. The one thing that is different between a very large number and a very small number is that for large numbers, the exponent is positive. For small numbers, in scientific notation, the exponent is going to be a negative number. Let's see how that plays out when we're actually doing these problems. Okay, the first one, I'm going to rewrite it as 0.0063. The first thing that we'll need to do is we need to figure out for our scientific notation, where are we going to put the decimal point? So let's go ahead and write the digits 6-3. So we need a number that's less than 10. So 63 is not less than 10, but 6.3 is less than 10, and it's larger than or equal to 1. So that works for our first factor. And then let's go ahead and write the times and write the base 10, because we know that will always be the same. What we need to figure out now is what will the exponent be? We know that because we're working with a really small number, it's going to be a negative exponent, whatever it is. Let's see how far away from the original decimal point our new decimal point is. So we'll count the place values. 1, 2, 3. 3 place values away from where it was originally. So that means that our exponent is going to be a -3. Again, we're working with a very small number. We're turning it into scientific notation. So with very small numbers, the exponent is going to be a negative exponent. Let's take a look at the next one. I'm going to make that full screen so it's a little bigger. I'll write the number down, 0.0427, and we can place the decimal point so that the number is, the first factor is going to be less than 10, but larger than or equal to 1. 4.27 is that. Now we'll write the times and our base 10. Now we need to figure out what is that exponent going to be. We're working with a very small number. It's a lot less than 1. So we know it's going to be a negative exponent. We just need to know what the value of that negative exponent is going to be. So here's where the decimal point was originally, and here is where it's going to go for scientific notation. Let's count how many place values we are away from the original. 1, 2. Okay, that was 2 place values, and so this is going to be a -2. Let's look at this next one. So this is point. We've got 4 zeros, 1, 2, 3, 4, and then a 6 and a 3. We need to make our first factor for scientific notation less than 10, but larger than or equal to 1. So let's put the decimal point there, 6.3, that works, times 10 to the what power? We need to figure that out. Okay, that's where the decimal point was originally. We are going to put the decimal point between the 6 and the 3. So let's count and see how many place values we moved. So 1, 2, 3, 4, 5. That was 5 place values. We're working with a very small number, so it's a negative 5. All right, so that's how you change a standard notation, very small number, into scientific notation. So let me record these on the sheet the way that you would write them down, right below the other number. And 6.3 times 10 to the negative 5. All right, that's how you would do the first half of this handout.